Humanity has always looked to Mars with curiosity, wonder, and a sense of possibility. For centuries, it was a distant red dot in the night sky, inspiring myths, science fiction, and scientific inquiry. Today, Mars is no longer just an object of imagination. It is the focus of one of the most ambitious and expensive exploration programs in history. At the center of this mission is SpaceX, a company determined not merely to visit Mars, but to make humans a multi-planetary species. Its vision is audacious: to transport people and cargo across hundreds of millions of kilometers, establish a permanent presence, and ultimately change the future of humanity forever. The idea of reaching Mars is far more complex than launching a rocket. It requires mastery over propulsion, life support, radiation protection, landing techniques, and sustainability. SpaceX has approached these challenges with an unconventional mindset. Instead of decades-long incremental development, the company pursues rapid prototyping, aggressive testing, and iterative design. Every explosion, every successful launch, and every failure provides data that accelerates progress. Central to SpaceX's Mars mission is the Starship spacecraft. Designed to be fully reusable, capable of carrying massive payloads, and optimized for long-duration space travel, Starship represents a radical departure from traditional spacecraft design. Its stainless steel body reflects heat efficiently during atmospheric entry, and its engines are engineered to provide both lift and precise control. The vision is not simply a single trip to Mars, but a scalable transportation system that can ferry dozens, eventually hundreds of passengers and cargo with each flight. Launching to Mars is only part of the challenge. Once on the Martian surface, humans must survive an environment that is cold, dry, and bombarded with radiation. SpaceX envisions habitats that can protect settlers while producing food, water, and oxygen locally. In situ resource utilization, such as extracting water from the soil or producing fuel from atmospheric carbon dioxide, is critical. These technologies are essential to ensure the mission is not merely a brief visit, but the beginning of sustainable settlement. Timing is critical for interplanetary travel. Mars and Earth align favorably only once every 26 months, creating a launch window that minimizes fuel consumption. Missing that window can delay missions for years, increasing both cost and risk. SpaceX's aggressive schedule is designed to take advantage of these windows, sending increasingly complex missions in succession to prepare for human arrival. Every launch is a step toward establishing the infrastructure that will allow a colony to grow and thrive. The implications of a successful Mars mission extend far beyond science. SpaceX's goal is to ensure humanity's survival in the long term. A single-planet species is vulnerable to extinction from natural disasters, climate change, or human-made catastrophes. By establishing a self-sustaining presence on Mars, SpaceX hopes to safeguard human civilization and inspire generations to dream bigger than ever before. The mission is as philosophical as it is technical. It is about ensuring that life continues, no matter what happens on Earth. Financial and logistical challenges are enormous. A mission of this scale requires billions of dollars, thousands of tons of equipment, and years of preparation. SpaceX leverages both private funding and government contracts, but its business model relies on reducing costs through reusability, mass production, and technological innovation. The risks are equally significant. Every stage of the mission, from launch to landing to survival on Mars, carries uncertainty. Radiation exposure, system failures, and human health challenges are all critical threats. SpaceX approaches these risks with careful engineering, simulations, and redundancy, but the human element introduces unpredictability that technology alone cannot eliminate. Yet it is precisely this willingness to accept risk that differentiates SpaceX from more conservative space organizations. Public perception has played an important role in shaping the mission. SpaceX's live-stream launches, ambitious timelines, and Musk's bold statements have captured global attention. The Mars mission is no longer a distant dream. It is a visible, unfolding story that inspires curiosity, investment, and public support. Science and exploration remain central. Beyond settlement, SpaceX missions will contribute to understanding Mars' geology, atmosphere, and potential for past or present life. Sample return missions, robotic scouting, and long-duration human operations will provide unprecedented data. Ultimately, the Mars mission of SpaceX represents a fusion of ambition, technology, and vision. It is not just a mission for engineers or astronauts, it is a mission for humanity. By turning Mars from a distant dream into an achievable destination, SpaceX challenges us to rethink the boundaries of exploration and the future of our species. Testing and preparation are at the heart of SpaceX's Mars mission. Every Starship prototype that explodes, tilts, or lands imperfectly provides critical lessons. Unlike traditional aerospace programs that often hide failures, SpaceX embraces them openly. Each test is a step closer to reliability, and each mistake accelerates learning. This iterative approach allows the company to compress decades of engineering development into a fraction of the time, giving humanity a faster path to Mars than previously imaginable. Refueling in orbit is another revolutionary concept central to the mission. Starship is designed to be refueled multiple times before leaving Earth's gravitational pull, enabling it to carry massive payloads to Mars without needing super-heavy rockets for a single-use launch. This approach not only makes interplanetary travel possible, but also dramatically reduces cost. By mastering orbital refueling, SpaceX is creating the infrastructure that could support repeated missions and eventually a permanent human presence on the red planet. Human factors pose one of the greatest challenges. Astronauts traveling to Mars will face long-duration microgravity, radiation exposure, isolation, and psychological strain. SpaceX and its partners are actively studying life support systems, artificial gravity simulations, and crew well-being strategies to prepare for these challenges. Every design choice, from cabin layout to exercise equipment to communication systems, is influenced by the goal of keeping humans safe and healthy for months-long journeys through space. Sustainability on Mars is another critical focus. SpaceX envisions habitats powered by solar energy, with systems capable of recycling air and water, producing food locally, and protecting inhabitants from radiation. This concept of self-sufficiency is essential because resupply missions from Earth will be limited and expensive. In addition, in situ resource utilization, extracting water, oxygen, and fuel from the Martian environment, will allow the first settlers to become partially independent, reducing the cost and risk of sustaining human life on another planet. The philosophical and societal impact of a Mars mission cannot be overstated. SpaceX has reframed human exploration as a multi-planetary endeavor, transforming a dream into a concrete goal. The company challenges humanity to think beyond Earth-bound limitations, inspiring scientists, engineers, and ordinary people alike. A successful Mars mission will not just be a technological achievement, it will redefine what is possible for our species, creating a vision of the future where humans are no longer tied to a single planet. Collaboration with governments and other organizations is also essential. While SpaceX leads the private sector in interplanetary transport, NASA and international space agencies provide critical guidance, regulatory oversight, and scientific expertise. Joint efforts, such as integrating Starship with NASA's Artemis program and potential Mars logistics planning, demonstrate how public and private sectors can work together toward a shared, unprecedented goal. This partnership model represents a new era in space exploration. Financing such a colossal mission is as complex as engineering it. Billions of dollars are required to develop spacecraft, infrastructure, and support systems for Mars. SpaceX offsets costs by offering satellite launches, cargo transport, and commercial space services, reinvesting profits into the Starship program. By creating a revenue-generating ecosystem, the company reduces dependency on government funding and accelerates development timelines. This strategy allows ambitious missions that would have been considered impossible a decade ago to become attainable within years. The first human missions to Mars will likely be small and highly controlled, focused on exploration, research, and testing sustainable life support. Each step will provide lessons for larger-scale settlement, including agricultural experiments, habitat construction, and energy production. SpaceX's vision extends beyond single expeditions. It is a roadmap toward a thriving, self-sustaining Martian colony. Each mission is a stepping stone toward that goal, with every success building confidence and every challenge prompting innovation. Ultimately, the Mars mission of SpaceX is about more than rockets and technology. It is about ambition, perseverance, and the desire to expand humanity's horizons. By tackling one of the most difficult, expensive, and high-stakes challenges in history, SpaceX is redefining what is possible for space exploration. The company's bold approach, relentless testing, and unwavering focus on Mars are turning a centuries-old dream into a concrete plan, inspiring humanity to look upward and imagine a future where life exists on multiple planets. As SpaceX moves closer to realizing its vision of Mars, the scale and ambition of the mission become increasingly clear. This is not simply a journey to another planet, it is a redefinition of humanity's role in the universe. Every prototype, every test flight, and every orbital maneuver brings the dream of a multi-planetary civilization closer to reality. The mission challenges not only engineering and science, but imagination itself, proving that the impossible can become achievable with focus, risk-taking, and determination. The first human steps on Mars will be historic, but they will also be just the beginning. SpaceX envisions a future where hundreds and eventually thousands of humans live and work on the red planet, building infrastructure, conducting research, and learning how to thrive beyond Earth. The mission is designed for scalability, where each success lays the foundation for larger missions, more advanced technology, and ultimately a self-sustaining presence on another world. What starts as exploration quickly becomes civilization building. The Mars mission also raises profound questions about responsibility, ethics, and collaboration. Ensuring the safety of the first settlers, maintaining sustainability, and preparing for long-term survival are challenges that require careful planning, international cooperation, and transparency. SpaceX is pioneering these strategies, but the endeavor will require contributions from scientists, engineers, policymakers, and dreamers around the globe. Mars is no longer just a destination for one nation or company. It is a project for all of humanity. At its core, the mission exemplifies the balance between audacious vision and disciplined execution. SpaceX has proven that bold goals are attainable when paired with iterative design, relentless testing, and calculated risk-taking. By turning Mars from a distant dream into a concrete objective, the company has inspired a generation to look up at the night sky with renewed hope and curiosity. Every launch, every prototype, and every challenge overcome is a step toward proving that life beyond Earth is not science fiction. It is a near-future reality. Ultimately, the Mars mission of SpaceX is a story of ambition, ingenuity, and perseverance. It is about humanity refusing to accept the limits of a single planet and daring to reach for the stars. The success of this mission will redefine exploration, expand the boundaries of science, and leave a legacy that endures for centuries. And when humans finally set foot on Mars, it will not only mark a triumph of technology and engineering, but a triumph of human imagination, courage, and the relentless desire to expand our horizons.